Building Scalable AI Agents, a Complete Architecture Guide. The Scaling Challenge. Picture this. You've built an AI agent that works perfectly in your demo. It answers questions, performs tasks, and impresses stakeholders. But then you deploy it to handle real-world workloads, and everything breaks down. Response times crawl, the agent forgets previous conversations, and it fails to handle complex multi-step processes reliably. This is the scalability gap that separates proof of concepts from production-ready AI systems. The difference isn't just about having a better language model. It's about architecting a sophisticated, layered system where multiple components work in harmony to create truly intelligent, scalable agents. The 8 pillars of scalable AI architecture. 1. Agentic frameworks, the orchestration layer. At the foundation of any scalable AI agent lies the orchestration framework. Think of this as the conductor of a symphony, coordinating different capabilities to create harmonious responses to complex tasks. LangGraph provides scalable task graphs that can handle intricate workflows with multiple decision points and parallel processing paths. CrewAI introduces role-based agents, allowing you to create specialized team members that excel at specific functions. One agent for research, another for analysis, and a third for execution. AutoGen enables multi-agent workflows where different AI personalities collaborate, debate, and refine solutions together. Supporting these frameworks, MetaGPT and LlamaIndex act as the connective tissue, stitching together knowledge sources and action capabilities into cohesive agent behaviors. 2. Tool integration, connecting to the real world. An isolated AI agent is like a brilliant scholar locked in a library with no access to current information or tools. Real scalability comes from seamless integration with the external world. Third-party APIs form the agent's sensory and motor systems, search engines for information gathering, code repositories for software development tasks, and databases for persistent storage and retrieval. OpenAI functions and tool calling provide structured execution frameworks, ensuring that when an agent decides to use a tool, it does so with precision and reliability. MCP, Model Context Protocol, serves as the standardization layer, enabling consistent tool chaining across different platforms and services. This means your agent can reliably combine multiple tools in sequence without losing context or making integration errors. 3. Memory systems, the foundation of intelligence. Memory transforms a reactive chatbot into an evolving learning agent. Without proper memory architecture, every interaction starts from zero, making true intelligence impossible. Short-term memory solutions like Zep and MemGPT maintain conversation context and immediate working memory. Long-term memory systems, using vector databases such as Pinecone and Weaviate, as well as solutions like Letta, create persistent knowledge that grows over time. The most sophisticated agents employ hybrid memory systems that combine episodic recall, remembering specific past interactions, with contextual reasoning, understanding how past experiences relate to current situations. This creates agents that don't just remember, they learn and adapt their behavior based on accumulated experience. 4. Reasoning frameworks, beyond simple responses. Raw language model outputs, while impressive, lack the structured thinking necessary for complex problem solving. Reasoning frameworks provide the cognitive architecture that enables sophisticated planning and self-correction. ReACT creates a feedback loop where agents think through problems step by step, take actions, observe results, and adjust their approach accordingly. Reflection adds self-evaluation capabilities, allowing agents to critique their own performance and improve their strategies. Plan and solve methodologies and tree of thought methodologies enable agents to break down complex problems into manageable components and explore multiple solution pathways simultaneously. These frameworks transform agents from reactive responders to proactive problem solvers. 5. Knowledge base, grounding intelligence in information. Scalable agents require robust knowledge management systems that can handle both structured and unstructured information at enterprise scale. Vector databases like Pinecone and Weaviate enable semantic search and retrieval, allowing agents to find relevant information based on meaning rather than just keyword matching. Knowledge graphs, such as Neo4j, provide structured relationship mapping, helping agents understand how different pieces of information connect and relate to each other. Hybrid search models combine the best of both approaches,
blending semantic retrieval with structured reasoning to provide comprehensive and contextually relevant information access. 6. Execution engine, the operational backbone. The execution engine is where planning meets reality. This operational layer handles the complex logistics of actually running agent workflows at scale. Task control systems manage complex workflows with retry mechanisms, timeout handling, and error recovery. Asynchronous operations enable agents to handle multiple requests simultaneously without blocking, while parallel execution capabilities allow for concurrent processing of independent subtasks. Latency optimization ensures responsive performance even under heavy loads, and scaling mechanisms automatically adjust resources based on demand. Platforms like Helicon provide the infrastructure monitoring needed to maintain consistent performance across varying workloads. 7. Monitoring and governance, enterprise-grade reliability. No production system is complete without comprehensive observability and control mechanisms. This layer ensures that AI agents operate safely, efficiently, and in compliance with organizational requirements. Langfuse and Helicon provide detailed analytics on token usage, response times, error rates, and behavior patterns. This telemetry data enables proactive optimization and issue detection before they impact users. Governance frameworks implement permissions, content filters, and compliance checks to ensure that agents operate within acceptable boundaries. This includes safety mechanisms to prevent harmful outputs and audit trails for accountability. 8. Deployment and interfaces, meeting users where they work. The final pillar focuses on making AI agents accessible and usable in real-world environments. This includes both the deployment infrastructure and the user interfaces that enable practical interaction. Interface options range from traditional chat UIs to integrated Slack bots and comprehensive dashboards that provide visibility into agent operations. Flow builders like Langflow and Flowiz enable non-technical users to create and modify agent workflows. Cloud-native deployment using Docker containers and Kubernetes orchestration provides the scalability, reliability, and maintainability required for enterprise operations. CI/CD pipelines enable automated updates and improvements, while edge deployment options bring AI capabilities closer to end users for improved performance. The integration challenge. The true complexity of building scalable AI agents lies not in any individual component, but in the intricate relationships between all these systems. Each pillar must communicate effectively with the others, sharing context, maintaining consistency, and handling failures gracefully. Consider a user request that requires the agent to research a complex topic, analyze financial data, and generate a comprehensive report. This single request touches every pillar. Agentic frameworks orchestrate the multi-step workflow, tool integration connects to research databases and financial APIs, memory systems recall relevant past research and user preferences, reasoning frameworks plan the analysis approach and validate findings, knowledge bases provide background context and domain expertise, execution engines manage the parallel processing of different research threads, monitoring systems track progress and resource usage, and deployment infrastructure ensures reliable performance throughout the process. The path forward. Building truly scalable AI agents requires a fundamental shift in thinking, from focusing on individual AI model capabilities to architecting comprehensive, interconnected systems. The organizations that succeed in deploying production-ready AI agents will be those that invest in building robust, scalable architectures from the beginning, rather than trying to retrofit scalability onto existing demos. The future of AI agents lies not in having the most powerful language model, but in creating the most sophisticated, well-integrated systems that can reliably deliver intelligent assistance at enterprise scale. Each of these 8 pillars represents a critical investment in that future, and together they form the foundation for AI agents that can truly transform how we work and solve problems. As we move forward, the winners in the agentic AI space will be distinguished not by their demos, but by their deployment capabilities, their ability to deliver consistent, reliable, scalable AI assistance that users can depend on for their most important tasks.